Have you ever looked at a solid copper wire and wondered what actually pushes the electricity from one end to the other? That invisible driving force is called voltage. Over the next few minutes, we are going to break down exactly how it works, so you can master this core concept. By the end of this session, you will know how to calculate circuit voltage, safely connect a measuring tool without damaging equipment, and confidently answer the most common interview questions on the topic. Most electrical failures involve a drop or loss of this pressure. Learning to measure and track voltage allows you to pinpoint exactly where a circuit is failing. In engineering terms, voltage is defined as the electrical potential difference. In Hindi, we refer to this as vidyut vibhavantar. It is the physical condition that forces electric charge to move. Let's compare this electrical circuit on the right to the water pipe system on the left. Translating the engineering terms into a physical analogy makes the concept much easier to visualize. Look at the mechanical pump. It generates the pressure needed to move the water. In our electrical circuit, the battery does the exact same job. The electrical pressure created by that battery is voltage. Now, as the pump pushes, water flows through the pipe. As the battery pushes, electrons flow through the wire. That physical movement of electrons is your current. If you turn off the pump, the water stops moving. If you remove the voltage, the current stops. Electrical current cannot exist without voltage acting as the instigator. We represent voltage with the symbol V, and we measure it in volts. You see this everywhere. A standard household AA cell supplies 1.5 volts. A car battery runs on 12 volts, and your domestic AC wall supply provides 230 volts. To measure this force safely, professionals use a specific diagnostic tool called a voltmeter, or a standard digital multimeter set to the voltage function. Here is a strict safety rule. A voltmeter must always be connected in parallel with the load. You must never wire it in series directly into the main path. A parallel connection works by measuring the difference in pressure across the component. The main electrical flow continues unimpeded through the resistor, while the voltmeter sits safely on its own separate track to read the difference. Wiring a voltmeter in series blocks the main path and can short the circuit or destroy the meter entirely. Knowing how to attach your tools properly keeps your equipment intact. You don't always need a meter to find the voltage. If you know the other properties of the circuit, you can calculate it mathematically using Ohm's law. This equation links our three main properties. V stands for voltage in volts, I is the current in amperes, and R represents the resistance in ohms. Let's apply this to a real scenario. Suppose a circuit has 2 amperes of current flowing through a load with 10 ohms of resistance. Take a second to multiply the current by the resistance. That gives us a total electrical pressure of 20 volts. This simple multiplication gives you the predictive power to map out exactly how much electrical pressure a circuit requires, long before you ever place your hands on a live wire. Now that we have the theory and the math down, let's test your retention against a few standard technical interview questions. First, what is the unit of voltage and which instrument is used to measure it? The unit is the volt. The tool is the voltmeter. Next, the safety question. How must that voltmeter be connected to the load? The answer is always in parallel. Finally, if you see a multiple-choice question asking you to identify the unit of voltage, you know instantly to select option C. Having these specific answers ready proves to any examiner or employer that you understand the basic mechanics of electrical circuits. You have successfully navigated the concept of voltage. You know it acts as the push, you know how to calculate it with Ohm's law, and you understand the strict parallel safety rule. With these concepts locked in, you are now equipped to handle basic electrical knowledge checks and practical tool setups. We have defined the pressure. Now we need to examine the actual volume of electricity being moved by that pressure through the wire. Mastering voltage is step 1. To complete your understanding of the circuit, click the next video on current and amperes, and let's keep building your foundation.